And action.
Yes, and we are recording, we're rolling. So today we're going to be talking about prime factors. Now, I've got a list here by each question of each of our prime numbers. Prime numbers, remember, are numbers that only divide by themselves or one. They only have two factors themselves. Our list is 2, 3, 5, 7, 11 and 30. Those are our 6 prime numbers, the first 6 prime numbers. So what I do here, if I want to find out all the prime factors of a number, in this case 96, first of all, I see if I can divide 96 by 2. So can I divide 96 by 2? Yes,
Yes.
I can. Yes, right. And that gives me 48. Next question, can I divide 48 by 2?
Yes.
So that means I get 24. Can I divide 24 by 2?
Yes.
Which gives me an answer of 12. And can I divide 12 by 2?
Yes.
And that gives me an answer of 6. And can I divide 6 by 2?
Yes.
And that gives me an answer of 3. Now I also notice that 3 is in my list as well, so I must circle it. When I've got 2 numbers at the bottom of my tree circled, it means I've finished. So 96 split into prime factors is going to be 2 times 2 times 2 times 2 times 2 times 3. Now that's an awful long way of writing things here. As I've got 2 multiplied 5 times, I put it in something called index form, which means I can write it as 2 raised to the power of 5. Remember, I've got 5 2's here, multiplied by 3. So writing it in index form, they ask you for that. That's how you'd write it in index form. Okay, we're going to come back to that a bit later, the making a perfect square. Let's go on to another example here on this board, where I've got to divide 375 and split that into our prime factors. So, can I divide 375 by 2?
No.
So what I have to do is I have to go on to the next number in my list. Can I divide 375 by 3?
Yes.
So dividing 375 by 3 gives me 125. Can I now divide that 125 by 3?
No.
No, so that means I cross out my 3 and I move on to my next number. Can I divide 125 by 5?
Yes.
So I divide it by 5 and that gives 25. Can I divide 25 by 5?
Yes.
So that gives me 5 as well, and I'm left with 5 again, so, which is in my list, so I circle it. As I've got my 2 numbers coming out which are circled, I've now finished. So writing this in index form, I have 1, 2, 3 5s and 1 3, so I write it as a 3 multiplied by 5 to the 3, indicating the 3 5s that I have there. Okay, on to the final example of prime factors. We then look at the number 550. So, cameraman, can I divide 550 by 2?
Yes.
So, 550 divided by 2 gives me 275. Tricky one now. Can I divide 275 by 3?
No.
No. So I cannot divide it by 2 or 3, so I have to go on to 5. Can I divide 275 by 5?
Oui.
So we have some bilingualism here from the cameraman, and dividing by 5 gives me 55. Can I divide 55 by 5?
Oui.
So 55 divided by 5, and that then gives me an answer of 11. Oh, 11 is also in my list. So I've finished my 5s, that means I've gone through the 7s, over to 11 now. So that means I've finished because I've got 2 circled numbers out of my last number. Writing it in index form gives me 2 times 5 squared times by 11, as I have the 2 5s here. If I've only got one of each number, remember, I don't have to write the one as an index. Now, sometimes you're asked, as an extension, how do I make this number a perfect square? Well, all I've got to do is look to see which numbers do not have powers of 2, 4 or 6 by them. In other words, powers with an even number. So, does 2 have a power with an even number by it? No. So I've got to multiply because it's 2 to the 1 because we don't see it. Does the 5 have an even number on a power? Yes, it does. It has a 2 there. So I don't have to multiply by 5 to make a perfect square. And does 11 have a power with an even number? It's got a 1. No, it doesn't. So I have to multiply by 11 as well. And 2 times 11 is 22. So in other words, to make a perfect square of 550, I have to multiply it by 22. That's a question you'll get at the end. Let's look quickly at the other two to do the same thing. So, does 3 have a 2, 4 or a 6, an even power by it? No. So I have to multiply by 3. Does the 5 have an even power by it? No. It has a 3, so I have to multiply it by 5 as well. And that gives us 15. So I'd have to multiply 375 by 15 to make it a perfect square. Finally, does the 2 have an even power by it? No, it's got a 5, it hasn't got a 2, 4 or a 6, I've got to multiply by the 2. Does the 3 have an even power by it? No, so I'd have to multiply by the 3 as well. So to make 96 a perfect square, I'd have to multiply by 6. Remember, perfect squares are an extension. So there we have it. This is how we find prime factors of numbers, display them in index form using a factor tree, and go on to make perfect squares.